So today we're going to cover chapter 14, which is human communication. This is biopsychology. We are going to talk about speech production and comprehension and the brain mechanisms that are responsible for that. What's really interesting about what we know about speech is that we look at the disorders that people have due to, for example, brain damage from stroke, to be able to learn more about how the brain processes speech, where we understand speech and where we recognize speech. And so a lot of what we're going to talk about today actually stems from disorder and being able to use a process of elimination to say, well, this person has damage in this area and that person has damage in that area, and they have these kinds of symptoms. So that's the reason why we spend so much time on disorder in this section, just because it helps us understand what mechanisms are working in what area. We're also going to talk about some disorders of reading and writing. Very briefly, at the very end of this slide deck, you're going to see a table that really sums up a lot of the disorders of reading and writing. We don't spend quite as much time on that in this lecture. So the three major things that we really need to talk about when it comes to speech is production, comprehension, and recognition of speech. These are three separate things. So production of speech is producing words in the right order with grammar, right? Comprehension of speech is simply understanding what someone is saying to you. And then finally, recognition of speech is simply understanding that what you are hearing is, in fact, words in speech. We're going to talk about a condition where the person can hear fine. They can physically hear the sounds, but don't recognize them as words and speech patterns. And so we'll talk a little bit about that. So just kind of starting out, a lot of the damage that we talk about in these kinds of disorders comes from a stroke or some kind of cerebrovascular accident. And so when you have a stroke is when you can have any kind of disruption of oxygen to the brain. And so if you have disruption of oxygen due to a blockage, you can have a rupture, you can have an aneurysm, which is different from a stroke, where you actually have a bubble sort of in your blood vessel. All of these things can cause these vascular events can cause damage to the brain. Anytime you have a lack of oxygen to any part of the brain, then you are essentially robbing it of nutrients because there's no fat storage in the brain. The brain needs to have nutrients as it uses them, and so it needs blood flow to areas that it's using to get oxygen and glucose and all those nutrients to be able to use them. And if you, even just for a few seconds, just for a few minutes, if you impede that, then it's potentially going to cause damage. And so what we're talking about here is any kind of occlusion or rupture in the blood vessel in the brain that's going to then lead to what we refer to as a lesion. And this lesion is, of course, damage to that particular area. And for cases that we see that have really large areas due to stroke damage, for example, the area sort of atrophies, it dies off, the tissue will die off, and you will actually see the area fill with cerebrospinal fluid in some cases, and you can see that on an MRI or CAT scan. So the things that we're going to talk about today is we're going to talk about aphasia. Now, aphasia is kind of like this big umbrella of any kinds of sort of disorders in speech. And so aphasia itself is difficulty in producing or comprehending speech. It's not produced by deafness. The person isn't deaf. They don't have an issue with their ears or the canals or anything there. They don't have any motor deficits. They're not able to form words with their mouth. There's no deficit there. They're able to form words with their mouth. And so aphasia is kind of this umbrella term that we use for any kind of speech disorder that would fall into the category of producing or comprehending speech that is just not, caused by any of these kinds of issues. And we're going to talk about the different kinds of aphasia here in a few minutes. So one thing that we've learned about the brain is that the two hemispheres of the cerebral cortex really are pretty balanced. there are motor strips on each side, there's somatosensory strips on each side, and there's a lot uh, of areas that are sort of synchronous to each other. They're not necessarily one side does this and one side does that, which we refer to as lateralization. They're pretty symmetrical. The one thing that we do know for a fact is lateralized is speech. So when I say that something is lateralized, what I mean is that a function or disability, an ability is localized to a particular hemisphere more so than in the other. So if you, for example, have damage in your left hemisphere motor cortex, for example, your right hemisphere motor cortex may try to take on some of that responsibility, and your deficits might not be as pronounced. When it comes to something like language is very lateralized to the left hemisphere. And so it doesn't matter if you're right-handed, it doesn't matter if you're left-handed. Everyone's language is really lateralized to the left hemisphere. And so what we find is that when there is damage to specific areas, like, for example, Broca's area, which is right here, or Wernicke's area, which is right here, this is just the left hemisphere, so not the right hemisphere, we find the most deficits when it comes to language. And we're going to go through each one of these and what's important for Broca, what's important for Wernicke. Now, before we go into in-depth the difference between Broca's area and Wernicke's area, what I really want you guys to know is that when we are looking at people with brain damage, whether it's caused by stroke, whether it's caused by traumatic brain injury, whether it's caused by a tumor, or any kind of condition, it's usually never a perfect little kind of damage, right? So it's never like, oh, it's just right here, and this is just where it's damaged. We can see people with, like, maybe they have a dot right here, and that's literally their damage. That's it. Or maybe they have this, where it's kind of overlapping a big area, or it's right here, and it's overlapping that area. So the brain damage that you see is often not clean. It's not just specific to a particular one little spot. Usually it's messy and it's overlapping. So even though I'm going to tell you the difference between Broca's aphasia and Wernicke's aphasia and all these different types of aphasia based off of where the damage is in the brain, it's often combinations of things. And it's often not just these symptoms and these symptoms alone. It can be very difficult to diagnose exactly what kind of aphasia a person might have. They may have some kind of symptoms that overlap each other. They may have, it's almost like a spectrum in some cases, where some people tend to have more abilities than others depending on where that damage is and how extensive it is in the brain. So let's talk real quick about something called apraxia. Now, apraxia is not aphasia, okay? So apraxia of speech is an issue with the production of speech where there's a problem with the movements of those parts of the body that produce sound. So, for example, your tongue, your lips, your throat, these are all required to produce proper sequences of speech sounds. And so apraxia would be when you have an impairment of to be able to program these movements. I like to kind of think of it as a disconnect between brain and body. And so some people find that if they have a child, for example, who is not making the right kinds of sounds early on, you would expect a child to say mommy or daddy really early on, and they're just not making those sounds. They're having a lot of difficulty forming the right kinds of movements with their mouth. That might be a sign of apraxia. So the child in that case can understand what you're saying, and they know that they want to say something, but there's a disconnect between what their mouth is doing and the structures of the mouth and what the brain is wanting to do. And so this disconnect can be very, very frustrating. It's also very frustrating to parents because children with apraxia, especially, they because they're not able to form words correctly, people sometimes treat them differently. And so they'll say, oh, your child's intellectually challenged. Well, there's nothing wrong with the child cognitively. It's just that they're not able to produce these kinds of sounds. And so a lot of times it gets very frustrating on a person with apraxia who's trying to get, trying to make these sounds, and it's not coming out, or it's not sounding correct. And so that can be very frustrating. And a lot of these conditions are very frustrating for the person who has them, especially as we start to talk about issues with producing speech but being able to comprehend it. And we'll talk about that next. So let's continue talking about producing speech. So let's start with Broca's aphasia. So Broca's aphasia is where essentially it's an issue with being able to produce speech, but the person can comprehend language usually just fine. Okay, so they're not able to produce words that are fluent. They are really struggling. They have a really hard time finding words, and they just really struggle with being able to produce the right kinds of words. So there's three major kinds of difficulties that a person with Broca's aphasia might have. So one is agrammatism, which is essentially they have a lot of problems with grammar. And so they may not be able to find the right words and the right endings to the words, like past tense, present tense, things like that. So an example would be if a person is looking at a picture of a boy being hit on the head with a baseball, for example, and you ask the person, can you tell me what's happening in this picture? A person who has an issue with this particular category might say, the boy is catch, the boy is hitch, the boy is hit the ball. And so they're trying to find the right words. They're not able to put them together grammatically correct for what's going on in a situation. Another issue that a person might have is anomia, which translates to without name. And this is just having difficulty finding the right word. And all people with aphasia omit words or use inappropriate words. So it's really a primary symptom of all aphasias. People with Broca's aphasia lack fluency, so it's especially apparent. And these individuals also tend to make facial expressions and say and a lot, which makes it very apparent that they're really searching for the right word. And we experience, difficulty finding words sometimes, and we're going to talk about that in a minute, about how this particular the area of the brain that's responsible for this is also related to things that people without aphasia do. But when we look at how a person is with Broca's aphasia might be struggling, so not only is it grammar, not only is it finding words, but also articulation. And so you might find a person mispronouncing words. They might alter the sequence of the letters, so like lipstick might become lickstip. And so they're just having difficulty getting the words and the letters all in the right order. But remember that they're able to comprehend language. And so this can be very frustrating for a person with Broca's aphasia because, they're having a really hard time expressing themselves, but they can understand what you're saying. And when I was working on my master's degree, I did a study on individuals who had stroke and looking at improving what sort of motor areas did they have as a result, deficits did they have as a result from their stroke. And so part of the project was doing an intervention, and then the other part was looking at just what areas of overlap of damage were there with different varying levels of motor ability. And so I was doing MRI and fMRI scans on individuals who were part of a group of people who participated a lot of times in different kinds of studies. And so they were used to getting in the scanner. They were used to, being scanned, and you would sort of explain to them what you want them to do in the scanner and how it's going to be, and consent them on the study. And that's just part of the whole process. Well, and for the individuals who had aphasia, and especially Broca's aphasia, it was very frustrating to them because if you have somebody new, for example, who's trying to explain something to them, they may sort of treat them like they're dumb and say, oh no, let me break it down for you so that you understand. And that in the individuals that had the aphasia were often very frustrated with that. So anytime we had anybody new on the study or a new student working with us, we had to explain to them, this person has aphasia. They can understand everything that you're saying completely, even though they're not really able to kind of tell you back what they mean. In one case in particular, there was a man that I scanned, and he would do sort of grunts, and he would say some words, but they were really, he had a really hard time, finding his words. And so, but he understood everything I said. And so I'd say, you're going to get in the scanner. He was kind of a larger man. And I said, it's going to be kind of tight. And he would sort of signal to me that he knew it was going to be tight by kind of pulling his arms in and saying like it was going to be a squish fit. So they are able to get their meaning across by making body movements and by nodding and, and sort of demonstrating that I'm following you. So it's a really interesting thing, but also very frustrating because they want you to know that I understand you. And so specifically with Broca's aphasia, we see that Broca's area is what's impacted. And so Broca's area is obviously very important for normal speech production because individuals with Broca's aphasia have issues with producing speech. And so this specifically is in the frontal cortex and is toward the front to base of the left to the left primary motor cortex. So it's rostral to base of the left primary motor cortex. And so we see that right here. So it's to the front. Now, when it comes to the other symptoms that we see of Broca's aphasia, we know that it doesn't just impact Broca's area alone. And as you pull back some of this tissue, you can get to the insular cortex. So the insular cortex is hidden in a typical brain picture, right? So you actually have to pull back these areas here. So you're pulling back the temporal lobe and you're pulling up the frontal lobe to reveal this area of the insular cortex. And this right here is sort of an extension into other area. And so we know that some symptoms of Broca's aphasia are going to involve those other areas, like the left precentral gyrus of the insula, for example. So this is a critical area. The insular cortex is a critical area for control of speech articulation. And so one thing that we've seen in different studies is that individuals that are really trying to get a word out. So for example, you might experience the tip of the tongue phenomenon where you know the word is on the tip of your tongue and it's right there. You are actually, this is the area here that's probably responsible for you experiencing that feeling, that phenomenon. And so if you have, for example, loss of gray matter in the insular cortex, you might experience problems with finding the right word. Because we know this area is important for finding words and for articulation as well. So that's Broca's aphasia. That is a type of aphasia. We're going to talk about another type. So that was production of speech, issues with producing speech. Here we're going to talk about another type of aphasia called Wernicke's aphasia, which is an issue with comprehending speech. So when it comes to Wernicke's aphasia, this is where a person is going to have difficulty understanding what someone is saying. Now, they don't tend to have issues producing language, even though the language that they produce is often sort of meaningless and nonsensical. The speech is really fluent, though. So it's unlabored, they're not straining, or they're searching for the word. It's very fluent. There's no struggle. It's like flowing right off the tip of their tongue. Whereas Broca's aphasia, it's not fluent. It's very broken. It's very labored. They're trying to search for words. Wernicke's aphasia, super fluent. What's really interesting about this is that they tend to string these words together, really super meaningless and very few content words. It doesn't seem like they don't even really seem to be aware at all of their condition. So I'm going to give you an example of what this might sound like. So, and there's also examples that I provided on Moodle but videos of different kinds of aphasia. But this would be an example. So if a doctor might ask, what kind of work did you do before you came into the hospital? A patient might say something like, and so this is me reading it off of of an example. So bear with me. I promise I'm not. There's nothing going on. I'm just kind of reading what a person has said with this kind of aphasia. Never now, Mr. Oig. I want you tell you this happened when he rent his cow come down here and he got rent something. It happened. In this rope ears with him for his friend like was. And it just so happened, I don't know, he did not bring anything around and he did not pay it. And all his rodent, all his arrangement from the pedis and the ispisket in his floors now and so, and he hadn't had them around here. So you can hear that there's words in there. And I'm speaking fluently. There's intonation. This is how an individual might sound. There's some made-up words in there. There's some meaningless words in there. There's words strung together. They don't make sense together. But if you kind of didn't think about what I was saying, it sounds like I'm speaking. It sounds like I'm talking. And so it's just a really interesting kind of way of expressing. And like I said, they don't seem to be really aware of their deficits. And they tend to be very sensitive to tone of voice, facial expressions. They have inflection in their own voice. They understand the rules of speech. So if you say something and you pause, or you ask a question with an upward inflection, they'll stop and they won't interrupt. And it's very like, it feels very fluent, but it is not. It doesn't necessarily make sense. Now, how do we assess to see if somebody can comprehend? We tend to ask nonverbal questions to assess comprehension. So, for example, you might have several items on the table, like a water bottle, a pen, maybe a phone, and then you say, okay, I want you to point to the one with ink. And if they don't signal to the pen, they signal to like the water bottle, then you know that they didn't understand. They didn't comprehend what you're saying. And so that means that, even though they're talking back to you and they're saying things, that they did not comprehend that. And that's a pretty good signal that they have Wernicke's aphasia.